Good evening, everyone. I'm Prince Selassie, Group Leader for Group 5A. Um, Please, sorry for the noise in the background and all that. I'll try as much as possible to make this presentation quick, that we don't waste a lot of time over here. So for Group 5, let me share my screen quickly. All right, I think my screen is being shared now. So for Group 5A, we are presenting on Chapter 5 from SES handout. That's design methods and processes. So these are our group members. And then the objectives we have for this presentation is that at the end of this presentation, we're expecting each and every one of us to know what human-computer interaction is like, just something small about it. And then the various design approaches in human-computer interaction, as well as the various design methods in human-computer interaction. So let's get straight to the point. So human-computer interaction, it is a study of how people react to systems and how they react to the systems in order to produce products that are productive and safe for the day-to-day activities of the people. So how the human beings interact with the systems for results to be produced. That's basically what human-computer interaction talks about. So moving straight to our main topic, which is design methods and processes. During our research, we got to know that since human-computer interaction deals with the interaction between systems and persons, it is mandatory or required that these systems are designed in such a way that the systems becomes easily for people to access them. Okay, and then the number of people or the kind of people that can access the system doesn't really matter. Like it should have a wide range. Okay, that's from the elderly people to the kids, the disabled people, etc. Please forgive me for the noise in the background. All right. So now what are design approaches when it comes to human-computer interaction? A design approach in human-computer interaction is the way a user interface or a system is developed so that a user-friendly, efficient, and intuitive experience is achieved. Okay, so we have traditional or old approaches that are used to design systems. All right, these kind of approaches, they don't really take a lot of user involvement in designing the system. But now, as a result of new governances and new laws that are being enforced, these old traditional methods are being taken out. And now the new approaches that are more human-centered, okay, that are more user-centered are being focused on. Okay, let me put it that way. So one thing we discovered is that when it comes to the designs in human-computer interaction, they are all backed by theory. There's no design that just comes up like that, like based on normal findings and all that. No, they are based by theories. They are principles, and then there are ways that they must be followed. Okay, so a common theory is based on activities the user performs. That's one theory, that the system will be designed based on the kind of activities the user performs. See, I think it's a little bit related to keystroke level modeling. I'll talk about that at the end of the presentation. And then there are other types of theories, like the activity theory for activity-centered design. So the activity-centered design is an example, or I would say it's an example of the traditional approach that doesn't really involve much of the user in developing the system. Okay, so let's go a little bit deeper into activity-centered design and see how it goes. And when we are done, we'll come to the new approaches which involves the user in developing the system. All right, so activity-centered design. It is a model, okay, activity-centered design is a model of a design that focuses on how a system produces an outcome as a result of activity. So they are focusing on how the system produces results based on the kind of activities that are involved. Okay, so the focus is on the whole system rather than just the user. It regards activity as the highest level of objective, backed by some form of motivation. So when it comes to, let's say, the activity-centered designs, they are not just like, you need some form of motivation is needed for, like, it's like more like the initial step is a form of motivation. I'll give you an example that will explain this further. So an example is like, let's say an activity of listening to music while driving. So now what is the task? The task is to what? Select um, what is the task? You're going to, it's either you use Bluetooth music or you select a radio station. Now, what are the actions that you perform? So you see, we are going with activities. You turn on the radio and you select a station. Then what are the operations? You press on the button, turn down to the right or left, like you are searching for the station. Then you see, so that's this the task. Select a radio station, action, turn radio on, select next station, operations, press on button, turn down to the right. Then now let's break it down and go into the activity nodes. So the first, as I said before, activity-centered approach or design has some form of motivation being its initial step. So what's the motivation of this activity where you want to listen to music in the car? So your motivation or your main aim is to avoid boredom, okay, or to avoid awkward silence whilst you are driving. Maybe with some people, everybody is quiet, you want to avoid that awkward silence, or you want to change the atmosphere in the car, or maybe for some personal entertainment. You get, so what is the goal or the outcome of this activity? It is what the resultant activity is, what music playing in the car. That's the main goal. Okay, so what's the object? The object or the receiver is the car. Then the subject or the creator is the driver and the passengers. The driver and the passengers are the subject or creators because they are the ones who, like, it's either the driver chooses the radio station or he inquires from the passengers what they want to listen to. So then when it comes to activity-centered designs, all these are processes or principles or entities that mix or come together. They have to work together for success or for a good result to be produced. Okay, so the community is one of them. That's other drivers, radio stations, division of labor. That's a passenger may or may not operate radio. So dividing the labor in developing this, the product. That's the final activity, which is listening to the music. So it's either the driver does it or the passenger can do it. And the rules and the rituals, that's go to favorite channel first, polite to ask passengers for input, requires minimal distraction to operate, time sensitive. So this part is talking about the rules that you have to follow or the normal things that they go about in the system. And then the tools and the artifacts involved in the system are the interface may be shared with GPS or maybe Bluetooth device, like the radio station where the sound is or the music is coming from. So this a model diagram of how the activity-centered design is. You see, all the different parts work together, and then with the activity-centered design, it's flexible. It's not some kind of rigid or linear design system. It's flexible. So where there are benchmarks, you can start and then still go back to where you started from. You don't necessarily have to follow one pattern. No, it gets flexible. So when you get to a particular benchmark where you've gotten to, you can still come back, come and develop from there again and move on. You see, that's how the activity-centered design is. Now, in the activity-centered design, we have 4 cyclic phases. Okay, they follow an iterative process for solving design problems. So now, these phases are the evaluation stage, requirement stage, design stage, and then the implementation stage. Okay, so as I said before, the part of an iterative process is not rigid and linear, but rather flexible. You see, the process continues until a sense of stability and resolution is achieved. Do you get it? Beautiful. Now, let's go to the types of design approaches that mostly include the user. That mostly includes the user. So we have the one, inclusive design. We are going to go through the inclusive design, accessible design, user-centered design, universal design, and a participatory design. I'm very, very sorry for the noise in the background. I'm on campus, and the bus is the one making that noise. So let's quickly go through the inclusive design. So inclusive design focuses on exploring ways of serving a full spectrum of people who make up a diverse market. This may involve different solutions or processes for different groups of people rather than a one-size-fits-all approach. You see, it is based on the simple principle that designing for the widest range of people creates better designs and benefits everyone. It takes into account what people say they need and want. So with the inclusive design, it's a design approach whereby the developer or the team has in mind everybody. They are not developing for, it's not like a custom made system. No, it's for the general public. And then in this general public, they are thinking of everybody, whether the old people, the young people, every single body, everybody is included in it. You see. So inclusive design is flexible. That's different people can use them in different ways. It's convenient. Everyone can use them without too much effort or separation. And then it's accommodating. That means that it can be used by all people, regardless of their age, gender, mobility, ethnicity, or circumstance. You get so with inclusive design, everybody is involved in it in the development process. They don't just do it for a selected few. At the end of it, I'll take you through some differences or some comparison between some of these design approaches. So now we have the another type of approach called the accessible design approach. So with this accessible design approach, it is a design process in which the needs of people with disabilities are specifically considered. So as compared to the inclusive design, the accessible design is more like a subset of it. Okay, so accessible design focuses on the outcome or end result of a design project. It's based on accessibility guidelines published by various governmental and industry groups, which aim to make sure people with disabilities can access websites and other digital products effectively. So with the inclusive, they just consider everybody, like let's say when they are designing an app for those who, or a system for those who cannot hear, they think about, okay, so if hearing impairment is going to be a problem, let's design a system that will cater for all those who have hearing impairments. Do you get it? But with the accessible ones, it's not like for everybody. If it is someone who is deaf, yes, that's the main person being considered, not someone who is deaf and considering another person who is dumb and all that. You see. So while, okay, there's an example here. So while inclusive design and accessibility are not the same thing, accessibility is one of the primary outcomes of an effective inclusive design process. So as I was saying, accessible design approach is more under the inclusive design process. Okay, so accessibility on its own, though will leave out large sections of the population who don't have a defined legally recognized disability, but may have issues interacting with interfaces based on particular circumstances in the environment. So as I said, unless um, your disability is legally recognized, it won't consider it. Do you get? It's not like the inclusive that considers everyone. Do you see? So let's move to the next type of design process, which is the user-centered design process or design approach. This is an iterative design process in which designers focus on the users and their needs in each phase of the design process. So at each stage of the design process, usability goals, user characteristics, environment, task and workflow for product and services or processes are given extensive attention. So with this one, the user is on the mind of the development team, where anything they are doing, they are thinking of the user. And the users play a very, very crucial role in the success of this design process. So in user-centered designs, designers use a mixture of investigative methods and tools, example, surveys and interviews, and then they generate some, like they brainstorm or they think of some of the problems or some of the needs of the users. Okay, so for a successful product, the development team of a user-centered design follow these guidelines. So let's go through the guidelines that they follow. So one, they have to understand the context of use, then the specifications or the requirements of the system, and the design solution, then they evaluate against requirements. So context of use. So they identify the people who will use the product, what they will use it for, and the conditions under which the product will be used. Okay. So now the class for the people that are going to use the system. Is it going to be used in the school? Is it going to be used in the mines? Is it going to be used in the hospital? You see that kind of context. Now, the user requirements, you have to identify any business requirements or user goals that must be met for the product to be successful. You see, the development team doesn't just sit down and then come up with their own ideas. No, they go to the low level of asking the users what they would like the system to do for them. You get it? Now, the design team creates or designs solutions. So the design team develops solutions either in stages or not by building from a rough concept to a complete design. So this one follows, it's like the agile method in software development. You get it? So it goes step by step, step by step, step by step. All right. Well, more like the waterfall. Yeah. So then they evaluate after the end of the whole design process, they evaluate the design. So over here, the outcomes of the evaluation are assessed against the user's context and requirement to check how well the design is performing. Okay, so testing is done with actual users. So with this one, the users come and test the system. Okay, so when they are testing, so this is the importance of the user-centered design guidelines. When your design team brings the users into every stage of the design process, you invest your effort and other resources into a powerful way of finding out what works well, what doesn't, and why. So you see, your users are an early warning system you can use to course correct and fine tune your design. Okay, they can expose many aspects, positive and negative, of like the positive and negative aspects of your system. And then your team may have overlooked all these things that they would have brought out. You see, so this is one of the important reasons why users are needed in the design process or in developing these systems, because they are going to use the system. So they are the best people to come and then test it. So for the developer, he will be like, oh, because he's more inclined or that's his field, certain things are there, he will overlook them thinking they are not necessary. But for an old man or for a young child, that thing that you would think is unnecessary might be necessary to them. You get it? For example, you see with the let's say when you are logging into a site, where you log in the placeholder, they write enter username. Even though they've written on top username, they'll still write enter username over here. So for the developer, he might think that, oh, somebody will be smart enough to know, okay, I'm supposed to put my username here. Do you get it? But with the help of a user testing it, the user can be like, oh, just in case someone forgets, you can place it over here so the person will be prompted again that I'm supposed to enter my username over here. Do you get it? Because different people have different ways of thinking. Let's move on. So another type of design approach or design process is the universal design. Okay, so with the universal design, it is the method of designing based on 7 universal design principles, okay, that work together to make environment, services, and products usable by the highest number of people. So some universal design principles include flexible use, simple use, and tolerance for error. Okay, so the main goal of the universal design, okay, is to remove barriers for all users. So with the universal design, it's just like the inclusive design. Everybody is on board. Okay, everybody is on board. So when using this design philosophy, designers create a single solution designed to reach the most people without the need to supplement the solution in order to accommodate for people with different needs. So just like the inclusive one, They are designing with everyone in mind. So they do a general thing that can suit everybody's need. If you want it to suit your personal need, then you have to come and do a custom system. You get it? So it's like, you see in architecture, when they are building story buildings, okay, the way they do the foundation and all that, when they are doing this estate, you see that most of the houses are the same. Yes, that's how the universal design approach is like. One particular system or one particular prototype will be used for everybody to suit everybody's need. You see. So if it's a place, you see some estates, there are swimming pools in all the homes. In some of them, there are no swimming pools in all the homes, all based on the kind of principles that they followed. So let's go through the 7 principles of the universal design approach. So the first principle is the equitable use. Okay, so with this one, the design is useful and marketable to people with diverse abilities. No group of users is disadvantaged. So it can be used by old people, it can be used by young people, it can be used by students, it can be used by workers, it can be used by illiterate. Every single person can use it. An example is like an example of an app is, let's say, WhatsApp. It's a WhatsApp, everybody can use WhatsApp. Everyone can use WhatsApp. Good. So the second principle is flexibility in use. The design accommodates a wide range of individual preferences and abilities. So with this one, the way you use the system, it has been designed in such a way that it can be used in a lot of ways. So if you like let's say, I don't know if this is a good example, but like for instance, you see when we are in the IDs that we used to code, some people like it dark mode, some people like light mode. So if you like yours dark, you can use it. If you like yours light, you can use it. You see. So the way you want to use your environment, you can design it or you can edit it to suit your preferences. Now the third principle is that it is simple to use. Okay, the use of the design is easy to understand regardless of the user's experience, knowledge, language, skill, or educational level. So no matter how high or low your educational level is, you can still understand the concept of the system and use it. Okay, so an example of such a system is like, I'll say the toll booth system. When you are going to pay your toll, you see when you get there, you just give the money, you take your ticket before the, the barrier is taken away for you to go. See, so such a system like this, you don't need to be educated, you don't need to be some kind of first class, like no, everyone can understand it and just follow the principles. So the fourth principle is perceptible information. So the design communicates necessary information effectively to the user, regardless of ambient conditions or the user's sensory abilities. The another principle is that tolerance for error. The design minimizes hazards and the adverse consequences of accidental or unintended actions. Then another principle is low physical effort. The design can be used efficiently and comfortably and with a minimum of fatigue. And the last principle is that the size and space for approach and use. So it has appropriate size and space provided for everyone, regardless of your body size and all that. Just like when you go to this picture, this picture shows how the design is. So this is like a shopping mall. The entrance, those who are working can freely, the door is wide enough for people to use. That's the number one, the equitable use. So you see this automatic sliding doors, when you get there, if you are disabled on the wheelchair, it automatically opens for you. You see, so everybody can use it regardless. And the flexibility in use, so just like a cutter, whether you are left-handed or right-handed, any way you want to use it, you can go about it. See, so, and then the size and space, that's the number 7. Size and space, see, they are passing through a terminal. I don't know if they are at the road station or an airport, you see. So the space for the man who can walk and the space for the one who's on a wheelchair, you see, is the same. A reasonable amount of space has been given considering these two class of people. You get it? So this is the principle, the considerations or the things taken in place when they are designing a universal system. All right, so the last design approach we are talking about is the participatory design. So when it comes to the participatory design, it is a process that involves developers, business representatives, and users working together to design a solution. So with this one, all the users, local business owners, everybody in the community becomes a legitimate stakeholder, right? So everybody's hand is involved. It's not only a design team that works on the system. No, every single person involved or who is likely to use the system is involved in developing the system itself. So some of the benefits of participatory design is it creates opportunities for people to meet and work together on a shared vision. This helps to build new social capital and strengthen existing networks. So I'll give an example. So let's say, you see, mostly when they are building, let's say they are building a school for a community. The design team is over there. The people who are going to use the system, the community members are also over there. So instead, if they are going to use a participatory design approach, instead of the design team going to hire laborers, the people in the community can serve as the laborers to do the work. So with that one, even money to hire laborers has been what? Been saved. Do you get it? And then people can coexist, the learned and then the illiterate working together. You see that it builds new relationships and strengthens their networks. So another benefit is that it involves constant reality checks. So the understanding of people's needs and interests is based on real findings rather than assumptions. So, okay, we are building the school for you. As they are building the school, since they are working with the people in the school, so the people in the school, when they are, you see, sometimes they can a company can come and do a project in one village, and the people will be complaining against that. They will have their own problems against what they've built. But if the people are participating in the design of the system, let's say they are building classrooms, and in the classrooms, they can give us, oh, the stairs you are making, why don't you do the pathway for those who use wheelchairs as well? Do you get it? When you go to chambers, you see KT has stairs at the same time. They have on the left side, right side, they have a path where wheelchairs can go, but chambers doesn't have it. Do you see? So this is a practical example. Do you get it? Yes. And then another benefit is that since all users are legitimate stakeholders, the participatory design creates space for the community to own the solution. So with this one, since everybody is working together in the system, nobody can own the system and say, the system belongs to me. I'm the only one who did it. You get it? The whole community is given that system. So when you go to some places, you see that, for example, our new petroleum block, you see they're putting GMPC School of Petroleum. Do you get it? So it means that GMPC is the main person who did it. But if they should have collaborated with a 50-50 percentage with UMAT, I'm not sure they would have. UMAT wouldn't have agreed for them to come and put their name boldly on the building. Do you get it? Yes. So we are done with the design approaches. In our objectives, we are going to know about the design approaches and then also the design methods. So we are done with the design approaches. Let's move on to the design methods in human-computer interaction. So when we talk about design methods are procedures, techniques, aids or tools for designing. Okay, so when it comes to our field, we are going to deal with the analytical methods. So there are two areas of interest for analytical methods. The first one is modeling humans and work. That is understanding of the human and the work they do, relevant for designing usability. And the next one is modeling design solutions. That's predicting the usability of the design solution, among other things like communication. So like with that one, you predict the solution, okay? But with the modeling humans and work, it's more like running through simulations and all that. So let's go deeper into it and see what it talks about. So we are going to task modeling. So task modeling is a method that allows designers to go through the steps users take in performing their task. The task model is a description of each task in a workflow. It defines attributes associated with the task. Okay, so the task model should be able to answer questions about the task world related to effective use of means. Okay, so it's like how do I even put it? You want to think like the user who is going to use your system. Okay, so you ask yourself these questions. How would the user do this? Is this necessary? Those are some of the questions over here. So one is, what are the critical tasks? How frequent are those tasks performed? Are they always performed by the same user? GC. And the adaptability too. What types of users are there? So you see, during the task modeling process, you take up the role of the user to ask yourself these questions so that you can develop a better system. If you don't do that, you will end up developing a system where nobody will like. Do you get it? So we have the dialogue. So the task modeling is one. Then we have the dialogue modeling. So when it comes to dialogue modeling, it is very, very important in human-computer interaction research. So for task model, the means can be used to determine some requirements for dialogue models that enable usability evaluation. So the dialogue model is like the feedbacks we get from the system. So so for example, when you are shutting down your machine and then you have some work that you've not saved, let's say you are working in Microsoft Word. When you do the activity, that's a task by clicking the close button. You see, it asks you, if not, are you sure you want to close down this, or some edits have not been saved, and they'll give you options to either save, not to save, or to close. Do you get it? So that's an example of a dialogue model. So the system communicates with the user. Okay. So a dialogue can be evaluated by looking at how well constraints are satisfied. So some of the questions are like the means. So the one is, when should the warnings be given? So for example, you can't, like, let's say when you are working on the machine, when you are typing, as you are typing, and then they will send you a pop-up. If not save the work, it's going to be annoying. If after every 5 pages you are being reminded to save, it will be a bit annoying. But then the right time to save the project is like, let's say you are accidentally shutting down your machine or restarting. You see that they will tell you that some works are still in progress or some apps are still open. Do you want to shut down anyway? You see, you want to shut down anyway. And even when you click shut down anyway, sometimes some apps, the priority some apps have over that one is high, in a sense that they will still require you to save their work or come and attend to that one, either save or not to save, before the system can even shut down. You get it? So let's move on. So we have the cognitive modeling. So we started with the task modeling, dialogue modeling, now we're on the cognitive modeling. All these are design methods, okay, steps to take in designing a system. After choosing an approach, some of the ways you can follow in designing the system. So the cognitive modeling, it involves creating a computational model to estimate how long it takes people to perform a given task. So this one is more like creating simulations and models to do the work for you. So you run the task through a simulation, okay, so that it can give you the time that's to take a normal human being to come and do the activity. So these models are based on psychological principles and experimental studies to determine times for cognitive processing and motor movement. So cognitive models can be used to improve user interfaces or predict problem errors and pitfalls during the design process. A few examples of cognitive models include parallel design and human process model. So with a parallel design, it's like different tasks are given to different developers. When they are done, and then the same resources are given to all of them. When they are done, they individually come and share how their tasks work, how they come and the evaluation and all that. They come and share it together. Okay, and then the human processor model is more like running things through the simulation or creating a model to do the task. Now, the last model is the keystroke level modeling. So with the keystroke level modeling, it is essentially a less comprehensive version of GOMS. Now, GOMS is an acronym. This stands for goals, operations, I think goals, operations, yeah, whatever, goals, operations, methods, and the S stands for selections. Okay. That's the booms. Let me quickly get back to where we were. Sorry about that. That makes simplifying assumptions in order to reduce calculation time and complexity. So with the keystroke level modeling, it summarizes all these elementary steps such as mouse clicks or mental operations, which are needed for finalizing the task. So keystroke level modeling requires only that the user interface be specified in enough detail to dictate the sequence of actions required to perform the task of interest. So the actions are termed keystroke level if they are the level of actions like pressing keys, moving the mouse, pressing buttons, and so more. The keystroke level modeling requires that we describe how the user level will do the task in terms of actions at this keystroke level. So the basic actions are called operators. Okay, and then there's a standard set of operators for use in the keystroke level modeling, whose execution times have been estimated from experimental data. So with the keystroke level model, you don't have to go through a whole lot of stress in order to design a system. So that one, they've brought everything down to just simple activities like clicking of the mouse, like when the user drags the mouse from the mouse pointer from here to this particular point, what are the statistics? Do you get it? So it predicts how long it will take an expert user to accomplish a routine task without errors using an interactive computer system. So moving the mouse pointer from one point to another point is an example. You see, it's an example of the keystroke level model. So with all this said, it comes to the end of our presentation. And these are the references where we got all our information from. So those who would like to do a further study, you can visit any of these references for more knowledge. I hope that I was able to present this portion of the course very well to your understanding. Thank you very much for your time, and we hope that our objectives were accomplished. Right.